Let's begin our unit on quadrilaterals. We're going to begin today by talking about how to classify polygons. And we'll talk about what makes a polygon. We'll give a definition of that so that we can classify them, and we'll also learn to identify them by their angle measures. So let's get started by, first of all, looking at polygons and figures that are not polygons. So see if you can come up with a definition of what makes a figure a polygon based off of these examples and these non-examples. I will just write down a definition in just a moment. But clearly you can see a difference that polygons have straight lines. These have curved lines. There's no open sides. Everything is closed off in a polygon, and there's no crossing of lines. So we'll put that all together in our definition here. So in geometry, a figure that lies in a plane is called a plane figure. So it's two-dimensional. And a polygon is a closed plane figure with the following three properties, or two properties. Can't count. Number one, it's formed by three or more line segments, which we call sides. So the smallest one would be a triangle. And each side intersects exactly two sides, one at each endpoint, so that no two sides with a common endpoint are collinear. So what that means is we've got each point is connected to at least two other points, and they can't be collinear. This wouldn't be classified because this side would have two sides all in a row. So they've got to be not collinear and at least three sides. Each endpoint is known as the vertex. Kind of like in triangles, we've referred to the vertices already. So polygon is named by listing the vertices in consecutive order. So I could say A, B, C, D, E, or C, D, E, A, B. Both those examples are correct, or any other example that follows in order. Next, we'd like to talk about what makes a polygon convex or concave. So in order to do that, compare the examples that we have there. And we're just going to take a look at that. What makes the difference between these? You might think that the concave ones look like they're caved in. That's the way that some people remember them. The official way to remember them is that convex, if I were to extend the lines of each side, I would never get into the interior of the polygon. But if I do that with a concave one, if I extend the lines, notice I hit the interior on these two examples. So convex we can define as a polygon where no line that contains the side of the polygon contains a point in the interior. But concave, we have a line that contains the side does contain a point in the interior. So take some time, pause the video, list whether these are convex or concave, restart it when you're ready to see the solution. So example 1 is not a polygon because one of the sides goes into the interior of the original figure. B is convex. If I extend the lines, nothing goes into the interior if I draw it correctly. C is not a polygon. We've got a curved side there. D is concave. If I extend the lines, they go into the interior. Next, let's classify polygons by their names. You see a three-sided figure is a triangle. Four sides a quadrilateral. We've got a pentagon, hexagon, heptagon, octagon, nonagon, which is a neat little song that you can listen to later on about the nonagon, decagon, dodecagon, and an n-gon. So if I had 17 sides, I could just call it a 17-gon. So just by the number of sides if you don't know the name of it. A couple other terms we want to keep in mind: equilateral polygons, all sides the same; equiangular, all the angles are the same. And a regular polygon means that angles and sides are congruent. So those are terms that we want to keep in mind. So take the time, using that chart, classify these polygons by their number of sides. So give it the name, and then tell whether it's equilateral, equiangular, or regular. Pause the video, start it when you're ready to check it out. So A, we have 6 sides. 6-sided figure is a hexagon. All the sides are congruent. All the angles are congruent, so it will be regular. B is a 4-sided figure, so it's a quadrilateral. Opposite angles are congruent and opposite sides are congruent, but they're not all the same, so it's neither equilateral, equiangular, nor regular. C, we have a 12-sided figure, which will make it a dodecagon, and it appears that all the angles are the same, but keep in mind that we've got 90-degree angles here, but since it's 90 on the exterior, this will make this 270. So just the sides are congruent, so that makes it just equilateral. So let's apply what we know now about regular figures. If this is a regular hexagon, how could we find the length of a side? If it's regular, all the sides are congruent and the angles. And if this gives the measure of a side, we can set up an equation saying, well, 3x plus 6 is equal to 4x minus 2. And we just solve that equation. So subtract 3x from both sides. And I have 6 equals x minus 2. Add 2 to both sides. And I have x equals 8. It asks for side length, so I can plug it back in. 3 times 8 is 24. Plus 6 is 30. That would be 30 inches. Make sure the other side is the same. 4 times 8 is 32. Minus 2 is 30 inches. So I did the math correct. They are the same. And that's all that we have for this lesson. Just getting into the definition of a polygon, talking about convex and concave polygons, identifying polygons, and determining whether they're equilateral, equiangular, or regular. So you'll do some work with that. If you have any questions, I'll take care of that in class.